Good morning. In previous session we have seen the phase lock loop, its block diagram and its pin diagram in detail. Now in this session we are going to discuss the following applications of the PLL. That applications can be frequency multiplication or division, frequency translation, amplitude demodulation, frequency demodulation, FSK demodulation, tracking filters, phase shifter, signal synchronizer, etc. But here we are going to discuss only few applications, that may be FM demodulation, AM demodulation, frequency multiplier, frequency synthesizer, timing distortion, or motor speed control. Now first we can consider frequency multiplier using IC 565. So here the figure shows the block diagram of a frequency multiplier using PLL. So we have different blocks available over here: phase comparator block, amplifier, low pass filter, voltage control oscillator, and one more block is added, that is divide by N network, that is frequency divider. A divide by N network, that is a frequency divider block here, that externally connected between the voltage control output and the phase comparator input in the feedback path. Thus, the two input frequencies to the PLL are Fs and Fo by N. So you can observe here, the PLL will try to make these two frequencies equal. For this, the voltage control oscillator actually operates at a frequency which is N times higher than Fs. So we can say Fo is equal to capital N into Fs or Fi. Thus the input frequency gets multiplied by N. The multiplying factor can be obtained by proper selection of scaling factor N of the frequency divider. So we have the multiplier using PLL and counter. The frequency multiplier with N equal to 5, it can be implemented using IC 565 and decade counter IC 7490. Here we have IC 7490 that can be act as a decade counter. So this IC 7490 is being used as divide by 5 network by configuring it as a modify counter. The transistor Q, it is being used as driver's transistor, which improves the sourcing capacity of PLL 565 and avoids its loading operation. So this transistor has been biased to operate as a switch. At the collector of transistor Q, we get inverted version of its base waveform that we can call as voltage control oscillator output. The output frequency is adjustable and it is possible to vary the output frequency by changing 20 kilo-ohm potentiometer. If you observe the circuit, we have 20 kilo-ohm potentiometer here. The PLL IC 565 is capable of operating at plus minus 5 volt supply voltage rather than plus minus 10 volt supply voltage. The capacitor C1 of 0.001 microfarad, here pin number 7 and 8, we have the capacitor of 0.001 microfarad. It is connected between pin number 7 and pin number 8. There is to avoid any possible oscillations, and capacitor C of 10 microfarad we have. It is larger enough to remove any high frequency ripple to ensure voltage control oscillator stabilization. Then we have you can use the same for the frequency division also. So the PLL can be used for a frequency division application. The same block diagram which we have seen previously over here. The same can be used for the frequency multiplication here. It can now be used for the frequency division. the voltage control oscillator output, which is a square wave, is rich in harmonics, that it contains many higher order harmonics, we can say. Therefore, it is possible to lock the nth harmonic of voltage control oscillator output with the input signal Fi. The output of voltage control oscillator is then given by Fo is equal to Fi by N. Now we can see the AM detector block using PLL. We have 4 different blocks here. The PLL can be used for detection of amplitude modulation signal. And if you observe here the diagram, we have phase shift of 90 degree. We have next block as multiplier that we can call phase detector block. And we have low pass filter, and finally PLL voltage control output is given to the multiplier, that is phase detector block. The block diagram of such scheme you can observe here. The AM signal or AM input, which is to be demodulated, is applied to the 90 degree phase shifting network as well as the PLL. So here if you observe both for phase shift 90 degree and for the PLL, we are applying AM input. The PLL is locked to the carrier frequency of the AM signal. Therefore, the voltage control oscillator output frequency is same as that of the unmodulated carrier. When the voltage control oscillator output is locked with AM signal perfectly, the phase shift between two is 90 degree. In order to nullify this phase shift, AM signal is phase shifted by 90 degree. This will bring both the inputs to the phase detector in phase. The phase detector circuit is basically a multiplier which will produce both sum and different components of frequencies at its output. The low pass filter will allow only those frequency components which are close to carrier and lower than it. The advantage of using the AM detector using PLL is its high noise immunity, which is not possible to obtain using conventional peak detector type of AM detector. Now we can see the next application as FM detection using PLL. Here again we have 4 different blocks, just like the PLL diagram: phase detector, low pass filter, error amplifier, and voltage control oscillator block. The FM signal, which is to be demodulated, it is applied at the input of the PLL. So the FM signal which we want, that can be applied as an input here. As the PLL is locked to the FM signal, the voltage control oscillator starts tracking the instantaneous frequency in the FM input signal. The error voltage produced at the output of the amplifier is proportional to the deviation of the input frequency from the center frequency of FM. Thus, the AC component of the error voltage represents the modulating signal, and thus at the error amplifier output we get the demodulated FM output. The FM demodulator using PLL ensures a high linear relationship between the instantaneous input frequency and voltage control voltage, that is error amplifier output. I repeat again, in this block diagram we can see or we can observe the FM signal which is to be demodulated, that is applied at the input of the PLL. As the PLL is locked to the FM signal, the voltage control oscillator starts tracking the instantaneous frequency in FM input signal. The error voltage produced at the output of the amplifier is proportional to the deviation of input frequency from center frequency of FM. Thus, the AC component of error voltage represents the modulating signal. Thus, at the error amplifier output, we get demodulated FM output. The FM demodulator using PLL, it ensures highly linear relationship between instantaneous input frequency and voltage control oscillator that we can call as the error amplifier output. If you observe here, we have the error voltage at the output of the error amplifier that can be applied as an input to the voltage control oscillator, and output of the voltage control oscillator is again fed back to the phase detector block. Here we can use frequency shift keying operation for the demodulator using PLL also. So different applications right now we have observed here. Few applications we have seen. The major applications we can consider about the frequency multiplication, frequency division, frequency translation, amplitude demodulation, frequency demodulation, FSK demodulation, tracking filters, phase shifter, and signal synchronizer. Now we have seen frequency multiplication, we have seen frequency division, then we have seen AM detection using PLL, and we have considered FM detection using PLL also. So PLL can be used as a frequency synthesizer also. So if you consider the frequency synthesizer, then in that case the circuit will be same as that of frequency multiplier, except for divide by M network, which is added on the input side after the crystal oscillator. We have to add that after the crystal oscillator. So frequency synthesizer is supposed to produce an output signal, the frequency of which it can be precisely adjusted to any value in a selected range. The output frequencies of a synthesizer should be very stable. In order to ensure that the stability of output frequency, a crystal oscillator of frequency F oscillator is used. The output frequency of crystal oscillator is divided by M with the help of frequency divided by M network. Thus the input frequency to the PLL is F oscillator by M. It is to be applied as the input. The PLL will compare this frequency with the frequency at the output of the divided by N network, and will try to adjust this frequency equal to F oscillator by M. So this is about the frequency synthesizer and different applications of the PLL.